projects. In this video, we are going to explain about a project titled Paddy Crop Disease Detection using Machine Learning. So now coming to the introduction part, Paddy Crop Disease Detection using Machine Learning represents a pioneering step towards a more resilient and sustainable agricultural sector. By fusing technology with agricultural practices, this innovation promises to bolster food security, increase yields, and empower farmers with the tools needed to safeguard their livelihoods. As we navigate the intersection of agriculture and technology, this approach underscores our commitment to harnessing innovation for the betterment of global food systems. Furthermore, this approach strives to bridge the knowledge gap between traditional farming practices and cutting-edge technology. By integrating machine learning into agriculture, it empowers farmers with an accessible and user-friendly solution to address disease challenges. So now coming to the objective part for this project, the Paddy Crop Disease Detection using machine learning extends beyond technological advancement. It is rooted in the commitment to elevate global agricultural practices. By leveraging machine learning for early disease detection, this approach empowers farmers with the tools to safeguard their crops, increase yields, and contribute to food security. As we strive for more resilient and sustainable agricultural systems, this innovation exemplifies a dedication to merging technology with the wisdom of traditional farming to create a more prosperous future. Moreover, this approach aims to democratize access to advanced agricultural technology. By offering an intuitive interface that integrates with smartphones or other devices, farmers, irrespective of their technical expertise, can utilize the technology to assess their fields for disease presence. This inclusivity empowers small-scale farmers to adopt proactive measures, leveling the playing field and contributing to more sustainable farming practices. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. So in hardware requirement, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. So now coming to the methodology part, first we have upload Paddy disease dataset. It involves the process of providing a collection of data related to paddy diseases to a computer system or software. This dataset likely contains images or information about different types of paddy diseases, their symptoms and associated attributes. Second, pre-processed dataset. It encompasses a series of steps to prepare the uploaded paddy disease data set for analysis. This might involve tasks like cleaning the data, handling missing values, resizing or standardizing images, and converting categorical information into numerical representation. Third, run SVM algorithm. It involves applying the support vector machine, that is SVM algorithm, to the pre-processed dataset. SVM is a machine learning technique used for classification tasks. Fourth, run CNN algorithm. It entails using convolutional neural network, that is CNN, for paddy disease detection. CNNs are deep learning algorithms particularly well suited for image analysis. Fifth, comparison graph. It refers to creating a visual representation that compares the performance of the SVM and CNN algorithms. This graph can display metrics such as accuracy, precision, recall, and F1 score on a testing dataset. The comparison helps assess which algorithms perform better in terms of disease classification accuracy. Sixth, predict disease from test image. It involves using the trained SVM or CNN model to predict the type of disease present in a new test image of a paddy plant. The model evaluates the features of the test image and makes a prediction based on the patterns it has learned during training. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder named as dataset. In this we are containing some other folders, and in all these folders we are containing some images over here. Another folder named as images, in this we are containing some images over here, and the folder named as model, in this we are containing some .npy files over here, and the other folder named as test images, in this we are containing some images over here for testing. And this paddy disease is a Python file which is containing the Python script in it, and here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. So now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. And now click on upload paddy disease dataset button to upload the dataset. Here I am selecting this dataset folder, and now click on select folder button to upload the dataset. So here on this screen you can see that the screen data set loaded, and in the graph x-axis represents Paddy disease and here y-axis represents image found in data set. So now closing this graph. Now click on pre-process dataset button to normalize, resize and shuffle and split dataset into train and test for getting out. So here on this screen in the text area displaying number of process image and then showing process the sample one image, and so now closing this image. Now click on run SVM algorithm button to get out. So here in this graph you can see that the CNN we got as the SVM we got as 40% accuracy, and in confusion matrix graph here x-axis represents predicted class and here y-axis represents true labels. And in this graph we can see SVM predicted so many images incorrectly, and so now closing this graph. Now click on run CNN algorithm button to get the graph. So here in this CNN we got 98% accuracy, and in this confusion matrix graph all different color boxes in diagonal. In this diagonal it represents correct prediction count and remaining blue boxes contains incorrect prediction count, which are very few. So CNN is accurate in prediction. And so now closing this graph over here. Now click on comparison graph button for getting the output. So here in this graph you can see that here x-axis represents algorithm names and here y-axis represents accuracy and other matrix in different color bars, and in this graph you can see CNN got high accuracy. And now closing this graph. Now click on predict disease from test image button to upload the image. Suppose here I am uploading this 5th image, and now click on open button to get the output. So here in this image you can see that Paddy disease predicted as brown spot over here, and in text we can see that it is showing over here that the Paddy disease predicted as healthy. So you can upload with other images and try with that also. So now coming back to the conclusion part, ultimately Paddy crop disease detection using machine learning embodies the spirit of progress and collaboration. By melding technological prowess with the vital task of feeding the world's population, this innovation underlines our commitment to advancing agriculture in a sustainable, resilient and equitable manner. As we navigate the complex interplay between technology, nature and human needs, this approach stands as a beacon of hope for a future where agriculture flourishes while ensuring the well-being of our planet and its inhabitants. This synergy fosters a holistic approach to agriculture that capitalizes on local knowledge while harnessing the benefits of cutting-edge technology. However, as with any technology advancement, this successful implementation of this solution hinges on addressing challenges related to data accuracy, regional variations and accessibility.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.